Hi, how are you? Hope you're doing well from the last lesson that we had. So today we are going to look at numerical integration, and we are going to derive the trapezoidal rule. So we are going to start with an opening statement that is going to help us come up with the trapezoidal formula. So we have the statement should be to evaluate the integral having a boundary of b and a with a fx dx, we subdivide the interval for a to b into n subintervals. So this is what we mean. The interval lies between b and a. So we have the main interval is between a and b. So we are being asked to find some sub-intervals between a and b. So we can have something like this. If we had a number line, we'll have this is a and this is b. Then we have sub-intervals. We into n, let's say this is 1, 2, 3, 4, 5, 6, and to go on up to b. So these are called sub-intervals. Those are sub-intervals. Then we say the area under the curve. The area under the curve in each subinterval. The area under the curve in each subinterval is approximated by the trapezoid formed by replacing the curve. So we are writing the statement to help us come up with the equation. So we've said the area under the curve in each subinterval is approximated by the trapezoid formed by replacing the curve by its secant drawn between the endpoints. Between the endpoints of the curve. So after that, the integral is then approximated by the sum of all the trapezoidal areas. So we have, then let's say, let h be the constant change in x, since the area of a trapezoid is its average height times the base for each subinterval. So we have up to that point we've said that the area under the curve in each subinterval is approximated by the trapezoid formed by replacing the curve by its secant drawn between the endpoints of the curve. So the endpoints of the curve are the A and B. So the integral is then approximated by the sum of all the trapezoidal areas. So we are going to draw a simple graph, an example. So we have, let's say this is our graph. Let's say this is our graph having a y and x axis. Then let's say our boundaries starts from here. This is A and this is B. So obviously we're going to have a line. Let's say this line is our y is equals to fx. That is our equation there. So we have this here. Then we are being told that the integral is then approximated by the sum of all the trapezoidal areas. Trapezoidal areas, they are formed like this. So we have, this is our A. So we draw the trapezoidal here, dividing them. We've been told that let h be the constant change in x. So we have, and we were told that we have subintervals between the boundaries A and B. So the subintervals here will be, let's say here we have, then we have that, these are subintervals. So these are the subintervals 1, 2, 3, 4, 5. And then we are being told that the integral is then approximated by the sum of all the trapezoidal areas. So we are going to have the area here, then we put all of them together. Then we are being told, let h be the constant change in x. So we have, sorry for that, from this point to this point is what we are calling h. From point A to point as the first subinterval, that change or that difference is what we are calling h. So h is equals to change in x. So we continue. Let's now come up with the formula. We've been told that let h be the constant change in x since the area of the trapezoid is its average height. Let's see how we are going to find the average height. So we have, let's say, having an integral, having, for example, the first x here and the immediate x of the subinterval or small x of the subinterval. So we are going to find h. So we have, let's say, for example, the upper boundary of that x is xi plus 1, and this is xi. Of course, this x should be greater than the lower boundary. That's why we are putting plus 1. Then we have fx dx, which is equals to, we want to find the average height. So the average height will be fxi plus fxi plus 1 divided by 2, change in x. So that's how we find our change in x. Then you're being told it's let h be the constant change in x since the area of the trapezoid is its average height times the base for each subinterval. So what are the bases of each subinterval? For example, we have, so if this is A, then let's label this as xi. That is xi, which is equals to A. Then we have this one, which is our x2. This is x3, x4, x5, or we remove this 5, we write x3. Then between x3 and xn, let's talk of xn here. We have, of course, many subintervals here between. So we have x1, x2, x3, xn to infinite. Let's say we have many subintervals, so we are going to reduce it into n. Then we have xn minus 2. We have this one will be xn minus 1. Then this one will be our n. So let's say this is n minus 3, n minus 3, n minus 2, n minus 1. Then this is the infinite n, the upper boundary of that integral. So we are being told times the base for each subinterval. So we are going to have, we've been told that the area is given by its average height times the base of the interval. So what are the bases of interval? So we've been told that the average height we always have is equals to the h over 2 or divide by 2. You multiply by the base. The base are given by fi plus fi plus 1. So, and for the main interval AB subdivided into intervals of sizes h. So we have the main integral, that is b and a. So we have fx dx is equals to, so because we have many subintervals here, so we are going to have, it is the summation, get it right, summation to infinite I is equals to 1, or to the nth value I is equals to 1. Then we have h, this formula that we've gotten here, h divided by 2. This is the constant change in x, that is in the subintervals, multiplied by the base fi plus fi plus 1. Then we have h over 2. So we have, of course, the subintervals, these subintervals, they have values. So the values are, let's say we have fi or f1 plus 2 f2 plus 2 f3. Then we have 2 fn plus fn plus 1. Then we have the formula h divided by 2. We have the first, or the lower bound, that is a, we are labeling it f1, plus fn plus 1, the upper bound, we put them into bracket, plus, because this 2 is recurring, so, or it is repeating itself, so we have 2 into bracket, the other f, so we have f2 plus f3 plus f, let's say 4 plus fn. Okay, so this is the trapezoidal rule or formula.